Alright, we've got 6 problems going over inscribed angles for some extra practice. So, let's find the following measures. First off, I want to find measure ABD. So I want to find the central angle. Since the arc is 100, that means the central angle is also 100 degrees. Okay, central angles are equal to the measure of the arc. Measure of angle A, it's going to be congruent to angle D. And the reason these two are congruent is because these are both the radius, and this is as well, but let's look inside the triangle. Since those are both the radius, these are also congruent. So there's two ways we could do this. We could do the triangle way, where we work inside the triangle and subtract from 180, or what we could also do is, since this is 100, this has to be 80 because those two arcs have to add to 180, and take 80 and divide by 2 because it's an angle that's on the circle, and you get 40. Now I already answered DC without realizing it. That's 80. And angle CBD is this angle right here, central angle for an arc that's 80 degrees. Problem 2, real similar. Find angle D. Angle D is on the circle. The arc across from it is 55, so 55 divided by 2 is 27.5. Angle DCE, so we're looking for this angle right in here. Because this is a straight line, I need to add this to 180, so this is going to be 125, and half of 125 is 62.5. Oh, I'm sorry. Not 62.5, that's a central angle, so that is 125. If we had an angle going from A, that would be 62.5. Arc AB is across from this arc, and because these two chords are congruent, these two arcs are also congruent, so this is 125 as well. And AD is opposite of this one. It's going to be 55. Let's put some degree symbols. Alright, find the following measures. We need angle C. We did a property that angles in a quadrilateral that are across from each other are supplementary. So 44 plus what gives me 180, and we're going to get 136. Let's erase it and start over. 136. Angle B is across from this one. Those need to add up to 180 also, and we get 102. And arc AC is this arc, and the angle that's cutting off that arc is this one. So we need to take 78, and we need to double it because it's something that's on the circle, and that's going to be 156 degrees for arc AC. Problem 4, a little bit more of the same. We have two lines that are parallel. Because they're parallel, let's start using alternate interior angles. We know these two will be congruent. Angle B, because this AC right here is a diameter, this angle is inscribed in a half circle. That's going to be a right angle. Angle BCA is the third angle in this triangle. 180 minus 90 minus 58 will get us that angle, and that's going to be 22. CD is over here. Since this angle here is 22, this angle here is also 22. When I double 22, I get 44 for that arc. And same for arc AB. Double the angle that's on the circle, and you get 44. Second to last one here, arc IJ is over here. This angle here is 55. That's not 55. Since this is 30, this angle right in here is half of 30, or 15, making this angle right here 40, because 40 plus 15 is this entire angle of 55, because it's HFJ. So since that's 40, double 40, and we get that arc IJ is 80. FH, the arc over here, is the remainder of this top half of the circle. That part's 30, this part over here is the remainder, so that's 150 degrees. And then GFH. GFH is this angle, we already found it, 15. And FGH, this angle here. Since we know that this arc is 150 degrees, that angle is a central angle, so it is congruent, and it's 150 as well. And now our last example. Anytime you see a ratio, remember you put x's behind it, so AC, first one goes with the first one, so 3x, CB has a 4, CB is down here, 4x, and this one's 5x. Now all of them add up because you're going all the way around a circle. They add up to 360 degrees. You get 12x equals 360, so we're going to get that x is 30 when you divide by 12. So now that I have x is 30, I need to find angle B. Well, I could find arc AC and get that this arc is 90 degrees. And the angle B is on the circle, so I take 90 and I divide by 2. I get that angle B is 45 degrees.